Here's the problem every developer hits when building a document assistant. You want a system that reads PDFs, understands images inside them, and answers questions about hundreds of pages of content. Standard approach. 3 different models, one for OCR, one for vision, one for text. Plus a vector database. Plus a re-ranker. What if you could do it all with one model call? MiniMax M3 was released June 1, 2026. It's the first open-weight model that combines 3 frontier capabilities in a single architecture, 1 million token context, native multimodal understanding, text, image, and video, and top-tier coding performance. 428 billion parameters, 23 billion active per token. MIT license. And its MSA Sparse Attention architecture makes that 1M context actually usable, not a marketing number. By the end of this video, you'll have built a multimodal document assistant that can ingest a 300-page PDF with charts and diagrams and answer any question about its content, using M3's API and a simple Python pipeline. Let me break down what M3 actually is. Architecture, mixture of experts with 428 billion total parameters. Only 23 billion activate per token. 128 experts, with 4 active at any time. This keeps inference fast and cost low, about 30 cents per million input tokens. The 2 breakthroughs, 1, MiniMax Sparse Attention, MSA. Standard attention scales quadratically with context length. MSA makes it linear. That's how they deliver a guaranteed 1M context with a minimum of 512k tokens. On a typical 50k token coding query, M3 costs $0.027 versus 55 cents on GPT 5.5. 20 times cheaper. 2. Native multimodality. M3 doesn't bolt on vision as an afterthought. It's trained on mixed modalities from step 0, text, images, and video together in the same token space. This means it understands the relationship between a chart and its caption, between a code screenshot and the surrounding text, between a flowchart and the documentation. The benchmark scores tell the story. Benchmark M3 score what it tests, SWE-Bench Pro 59% real-world coding, GitHub issues, Terminal Bench 2.166% terminal execution tasks, BrowseComp 83.5 autonomous web browsing, MMU frontier-level multimodal understanding, human eval state-of-the-art code generation. Here's the architecture for today's build. A multimodal document assistant with 3 stages. Stage 1, document ingestion. We take PDFs, images, and mixed media documents. M3 natively reads them, no separate OCR step needed. It sees the text, the charts, the tables, and the layout simultaneously. Stage 2, smart chunking with M3. Instead of naive text splitting, we use M3 to identify logical document boundaries. A chart plus its caption becomes one chunk. A table plus its footnotes becomes another. The layout is preserved. Stage 3, hybrid Q&A. For short queries, under 32k tokens, we feed the entire document to M3. For long documents, we use vector search to retrieve relevant chunks, then feed them to M3 for synthesis. The result, a document assistant that actually understands visuals, respects layout, and answers accurately across hundreds of pages, with a single model. First, get API access. Go to platform.minimax.io, create an account, and generate an API key. Alternatively, M3 is available through OpenRouter, NVIDIA NIM, and Together AI. We'll use the official MiniMax API for this tutorial. Test your key, bash curl https://api.minimax.io/v1/chat/completions/h authorization, bearer $minimaxapiki /h content type, application/json /d model, minimax M3, messages, role, user, content, hello, what can you do, max tokens, 100. Response should come back in under a second. Welcome to M3. Install the Python client, bash pip install OpenAI compatible SDK works pip install pypdf2 for PDF parsing pip install ChromaDB for vector storage. MiniMax's API is OpenAI compatible, so we can use the standard OpenAI Python package. Just change the base URL. Here's the core ingestion pipeline. Unlike traditional RAG that treats PDFs as flat text, M3 sees them as multimodal documents. Python ingest.py, multimodal document ingestion with M3 from OpenAI import base 64 from pathlib import path client equals OpenAI, a PyKey equals your MiniMax API key, baserl equals https://api.minimax.io/v1, def encodimage base 64, image path, str-str. With open, image path, rb, as f, return base 64.b64 encode, f.read.decode, utf-8, def understand document chunk, text, str, images, list, str equals none, structure, str equals none, dash str, feed a document chunk, text plus images, to M3 and get a structured understanding back. Content equals, add structure description if available if structure, content.append, type, text, f, document structure, \n content, text, else, content.append, type, text, add images inline if images, for inpath and images, b64 equals encodimage 64, inpath, content.append, type, imageURL, URL, f, data, image/png, base 64, b64, detail, hi, response equals client.chat.completions.create, model equals, minimax, M3, messages sad face, role, user, content, max tokens equals 2048, temperature equals 0.1, return response.choices, 0, .message.content. The key insight. We pass images as imageURL with base 64 encoding, right alongside the text. M3 processes them natively, no separate OCR model needed. For PDFs with mixed content, Python def processed page, path, str, paginam, int, extract both text and image regions from a PDF page. Import pypdf2 from PDF2 image import convert from path extract text reader equals py. Standard RAG chunks by character count, 500 characters here, 200 there. That breaks tables, splits figures from their captions, and destroys document structure. M3 lets us chunk intelligently because it understands layout, Python smart chunk.py, visual aware document chunking def identifylogicals, text, str, page images, list, str, dashed list, dict, use M3 to identify logical document boundaries. Return structured chunks preserving visual text relationships. Ask M3 to analyze document structure analysis equals client.chat.completions.create, model equals, MiniMax M3, messages sadface, role, user, content, type, text, analyze this document and split it into logical chunks. A chunk is a self-contained unit, a section, a figure with its caption, a table with its header, or a code block. Return a JSON array of chunks with their page numbers and content types, type, imageURL, URL, f, data, image/png, base 64, img, for img in page images, 5, first 5 pages, response format equals, type, John object, temperature equals 0.0, import JSON return JSON.loads, analysis.choices, 0. Message.content, the output is a structured chunk list, JSON, type, section, title, executive summary, pages, 1, contains images, false, token estimate, 1200, type, figure with caption, figure it, figure 1, caption, revenue growth Q1, Q4 2025, pages, 2, contains images, true, token estimate, 800, type, table, title. Financial projections, pages, 3, contains images, false, token estimate, 2500. For documents longer than 32K tokens, we can't fit everything in context. That's where vector search comes in. But instead of using a separate embedding model, we can use M3's own representations. Let's set up ChromaDB, Python vectorstore.py, build a searchable index of document chunks, import chromad from chromad.utils, import embedding functions, initialize ChromaDB, chromaclient equals chromad.persistentClient, path equals ./documentstore, collection equals chromaclient.getCreate collection, name equals documents, embedding function equals embedding functions.default embedding function, def index chunks, list, dict, documented, str, index smart chunks for vector search. Documents equals, metadatas equals, IDs equals, for I, chunk and enumerate, chunks chunkit equals f, documented, I, create a rich text representation of the chunk content equals f, chunk, type, .upper, chunk.get, title, \n, for image containing chunks, describe what's visible if chunk.get, contains images, content plus equals, this chunk contains images / visual data, \n, content plus equals chunk.get, text, documents.append, content. Metadatas.append, docid, documented, chunk, type, page, chunk.get, pages, none, 0, has images, chunk.get, contains images, false, IDs.append, chunkid, collection.add, documents equals documents, metadatas equals metadatas, IDs equals IDs, def retrieve relevant, query, str, results, int equals 5, dash list, str. Retrieve the most relevant chunks for a query. Results equals collection.query, query text sadface query, results equals results, return results, documents, 0, if results, documents, else. Now the Q&A function combines retrieval with M3 reasoning, Python QA pipeline.py, full Q&A with retrieval plus M3 synthesis def answer question, query, str, entire document, bool equals. Let me show this working on a real document, a 200-page financial report with charts, tables, and dense text. I load the PDF, run the ingestion pipeline, Python from ingest import processed page from smart chunk import identifylogicals from vector store import index chunks process first 10 pages to test all chunks equals 4 page and range 10 understanding equals processed page annual report 2025.pdf page chunks equals identifylogicals understanding get page images page all chunks.extend chunks print f indexed len all chunks logical chunks across 10 pages output indexed 47 logical chunks across 10 pages. Now I ask questions. Query 1, text only. Question: what was the total revenue for fiscal year 2025? A. According to the financial summary in the executive overview section, page 1, total revenue for FY 2025 was $847.3 million, a 23% increase YOY. Query 2, visual plus text. Question: what chart shows the revenue breakdown by segment? A. Figure 2 on page 3 shows the revenue breakdown. The pie chart indicates Enterprise SaaS, 58%, SMB, 22%, Professional Services, 12%, and Other, 8%. The surrounding text confirms these percentages align with the Q4 2025 earnings call. Query 3, cross-page reasoning. Question: how did the gross margin trend over the year? A. From the financial data across pages 5 to 7, gross margin increased from 68.2% in Q1 to 72.1% in Q4. Table 4 on page 6 shows quarterly breakdown. The chart on page 7 confirms the upward trajectory. M3 correctly references specific figures, pages, and chart types, because it understood the document as a multimodal whole, not just scattered text. 3 ways to extend this beyond PDF Q&A. Extension 1, Video Document Understanding. M3 natively processes video frames, Python def analyze a video frame, video path, str, timestamp, str, extract frame and analyze with M3. Extract frame at timestamp using ffmpeg framepath equals /tmp/frame.jpg subprocess.run ffmpeg ss timestamp I video path frames 1 framepath return client.chat.completions.create model equals MiniMax M3 messages sad face role user content type text describe what's happening in this video frame from a product demo type imageral URL base 64 frame extension 2 document agent with tool calling. M3 supports function calling. Give it tools to query the document store, Python tools equals, type, function, name, query document, description, search the index document store, parameters, type, object, properties, query, type, string, description, search query, required, query, extension 3, computer use agent. M3 can see screenshots and decide actions, clicking, typing, scrolling. This turns it into a true autonomous document processing agent. Let's talk cost, because this is where M3 really shines. For a typical document Q&A task, 50K input tokens model input cost processing 200-page report, MiniMax M3 30 cents per M tokens $0.015 per query GPT, $5.52.50 per M tokens $0.125 per query Claude Opus $3 per M tokens $0.150 per query M3 is 8-10x cheaper than equivalent frontier models. The secret, MSA Sparse Attention. Standard attention computes every token pair, O, N superscript 2. MSA skips irrelevant pairs, effectively O, N. At 1M context, that's the difference between 30 cents and $15 for a single full context pass. For our 200-page report ingestion, full document scan with M3, $0.60, same with GPT, 5.5, $5.00, with vector search retrieval, $0.03 per query. 3 things to remember. 1. MiniMax M3 is the only open-weight model that delivers 1M context, native multimodality, and frontier coding in one package. 2. For document assistance, M3 eliminates the multimodal pipeline. 1 API call to understand text plus charts plus tables plus layout together. 3. At 30 cents per M input tokens, M3 makes document AI affordable at scale. No more juggling between a cheap transcription model and an expensive reasoning model. Full code for the document assistant pipeline, ingestion, smart chunking, vector search, and Q&A is linked in the description.